In February 2023, Mitsubishi Heavy Industries made an announcement that shook the aviation world. After 15 years of development, after $10 billion spent, after flight tests, airline orders, and a brand new factory in Washington state, they were completely canceling the SpaceJet program. The plane had flown, it worked, it had orders from ANA, JL, but also from American regional carriers, but it would never carry a single paying passenger. Meanwhile, the same Japanese engineers, unable to finish their own jet, are designing carbon fiber wings for the 787. They manufacture the fuselages of the 777. They produce parts that literally hold Boeing's most advanced aircraft together. So here's the question. If Japan helps build the world's best passenger aircraft, why can't it build its own? This isn't a story of bad engineering. Japan has some of the best aerospace talent on the planet. It's a story of timing, politics, and an industry designed to penalize new entrants. And it starts with a decision made in 1945 that set Japan back an entire generation. Just before starting, I want to say that Japan excels in military aircraft and special missions like Kawasaki's C-2 tactical transport, and also Shinmaiwa's US-2 amphibious rescue aircraft. But this video focuses on civil passenger aircraft where market barriers and regulations are much tougher. To understand, we need to go back to 1945. When Japan surrendered, these wartime aerospace giants, Mitsubishi, Nakajima, Kawasaki, were among the most advanced in the world. These companies had built legendary fighters and mastered high-performance aircraft design better than almost anyone. Then the Allied occupation imposed a total ban on Japanese aviation, no more new aircraft engines or test programs. Even aviation research was banned. Students could no longer study aeronautics. Gliding was forbidden. This ban lasted 7 years until April 1952. 7 years that seemed like an eternity in a field that never stops advancing. Here's everything this ban destroyed. It wasn't just factories and assembly lines. Entire teams of engineers moved to cars, trains, or heavy industry. Design offices closed. Wind tunnels were converted. Industrial tools discarded. The institutional memory that enables aircraft development, design know-how, systems integration, certification culture, all disappeared. While Japan remained frozen, Europe and the United States didn't wait. They transitioned from piston engines to jets. They built the DC-8, the 707. They developed modern air networks and certification systems that became the global standard. When Japan was able to return to aviation in 1952, the train had already left. Boeing and Douglas had become strong global brands. Airlines were already integrated into Western supply chains. Japan wasn't just a bit behind, it was an entire generation behind, with no civil line, no customers, and no certification history. This lesson became etched in government policy. Trying to come back strong would be extremely risky, but also costly. But they had to try. And what happened next would shape Japanese aerospace strategy for decades. In the late 1950s, the government and industry created NAMC, Nihon Aircraft Manufacturing Corporation, a consortium of 6 major manufacturers pooling resources and talent. The goal? Design and build a domestic turboprop for regional routes, prove that Japan can build aircraft again. The result was the YS-11, a 60-70-seat turboprop intended for the short-haul market. The design team included Jiro Horikoshi, already known for designing the Mitsubishi A6M0 fighter, real talent. The plane flew well, it was generally reliable. Japanese airlines JAL and ANA chose it. JAL and ANA's initial investments locked them into Western ecosystems. Adoption of the Boeing 727 in 1965 under government pressure to facilitate U.S. imports, and DC-8s and 737s in the 60s-70s for their reliability, while U.S. export financing and political alliances made Boeing a safe choice compared to unproven local designs. A few international customers bought small fleets. Even when American companies like Piedmont Airlines launched operations with 23 YS-11s, the largest foreign fleet, after-sales service was problematic. Rare spare parts stock internationally, Inconsistent documentation and limited training discouraged repeat orders from cautious operators. For a time, people believed Japan might succeed, but problems emerged. Development costs exploded. The plane was neither clearly cheaper, lighter, nor more efficient than its foreign competitors like the Fokker F-27, no strong sales and support network outside Japan, spare parts, training, marketing. Everything was less developed than Western players who had been present for decades. And here's the structural problem that would also doom Japan's second attempt. NAMC was a state consortium grouping several manufacturers. Design choices were compromises to please everyone. Profit and long-term commercial competitiveness took a backseat to industrial policy and national prestige. The program's mindset was closer to a military project than commercial. An obsession with performance criteria imposed by the state prevented truly meeting the expectations of commercial operators. Airlines care about operating costs and cabin configuration. NAMC optimized mainly to check bureaucratic boxes. The result? About 182 aircraft built between 1962 and 1974. Not bad for a first attempt, but insufficient to sustain the program. The economics didn't work. The program depended on government subsidies throughout its music existence. In 1971, the Japanese government announced it was ending funding. The program was losing money and stopped. Japan learned a clear message. Launching a completely local airliner program is financially risky. Japan can build the machine, but winning the market is another story. The YS became a lesson for management for decades and triggered a strategic shift that would define Japan's role in aviation for the next 50 years. After the YS-11, the idea of another entirely Japanese commercial aircraft became politically taboo. No one wanted to risk it. Money had been lost, pride wounded, but Japanese industry understood something smarter. Boeing, Airbus, then Bombardier and Embraer need ultra-qualified suppliers. Japan can guarantee reliable revenue by manufacturing sections rather than entire aircraft, letting someone else take the market risk. The government's industrial policy turned toward high-tech materials, precision components, and also risk-sharing partnerships in foreign programs. It was a strategic retreat, and it worked. Japanese companies, Mitsubishi Heavy Industries, Kawasaki Heavy Industries, and Fuji Heavy Industries took major roles on the Boeing 767, 777, and 787 music. On the 787, Japanese manufacturers supply about 35% of the parts, the wings, center wings, forward fuselage, more than a third of the entire aircraft. On the 777X, they supply about 21%, the center section, center fuselage, and aft fuselage. These aren't small components. These percentages show that Japan is a key partner in these two programs. The big advantage: stable, long-term contracts worth billions, technical expertise on cutting-edge structures, strong ties with Western OEMs. Risk sharing on the 767 and 777 gave Japanese firms quasi-OEM experience, design power over wings and fuselages without the full program risk, like creating their own sales network or chasing airline certifications. Predictable revenues, not dependent on direct sales to airlines. But here's the hidden cost that would catch up with them. Japanese aerospace genius specializes in subsystems, not complete system design. Sure, they become world experts in wing manufacturing, but lose practice integrating wing, fuselage, avionics, engine, and flight controls to build a complete aircraft. No end-to-end in-house experience of a civil aircraft program accumulates over decades. The know-how on certification, marketing, sales, and support of a complete aircraft gradually fades. When it's time to try again, Japan will actually be a newcomer once more. And that's where things get really costly. In the early 2000s, pressure mounted to climb up the value chain, no longer be just a parts supplier. Government officials and industry leaders began asking, why not build our own jet? Mitsubishi Heavy Industries launched the MRJ, later renamed SpaceJet, Japan's bet on redemption, targeting the 70-90 seat regional market dominated by Embraer and Bombardier. This market was highly coveted. Airlines wanted fuel-efficient regional jets. The MRJ-70 accommodated between 70 and 80 passengers, the larger MRJ-90 between 86 and 96. The key arguments: advanced aerodynamics, new Pratt & Whitney geared turbofan engines, more fuel-efficient, comfortable cabin, designed with Japanese attention to detail. Mitsubishi announced the concept in June 2007, aiming for certification by 2012. 5 years, that shouldn't be so hard. No, it was extremely hard. Mitsubishi had great engineering talent, but almost no experience leading a complete civil program or managing Western-style certification, especially FAA certification. They were brilliant at making wings for Boeing. But building an entire aircraft is a whole different ballgame. Problems came quickly: rising weight. The plane became heavier and heavier as design confronted reality. Systems integration bugs, certification requirements, forced rethinking of structure and systems, specific failures, incomplete system documentation for FAA traceability, double wiring but not to standards, avionics integration bugs that required complete redesign, revealing a lack of Western certification culture. 4 of the 5 delays were due, at least in part, to documentation failures for certification or similar. Mitsubishi later admitted not really understanding from the start the complexity of the type certification process. They planned a final assembly line in the United States at Moses Lake, Washington, for flight tests and to be close to FAA regulators and customers. But even that couldn't fill the real experience gaps. This institutional knowledge about certification culture, lost during 7 years of pause, never fully returned. Each correction added delay, each delay increased costs, each additional cost undermined airline confidence, leading them to wonder if this jet would ever arrive. Airline support was real, though. Firm orders from ANA, JAL, and also U.S. regionals like SkyWest and Transstates, plus letters of intent from others, proof of interest but insufficient to withstand the delays. And then there's the American scope clause trap, and that one is truly cruel. The SpaceJet mainly targeted the American regional market, but there was a problem no one at Mitsubishi had really anticipated. Pilot union scope clauses limit regional airlines to aircraft under 86,000 pounds maximum takeoff weight and 76 seats maximum. It's a job protection agreement for mainline pilots. The first MRJ versions exceeded these limits, and very quickly it became clear these rules wouldn't change. Mitsubishi had to revise its designs, split variants, and completely rethink its target market. They had planned to develop the smaller M100 version to meet these scope clauses. Years passed. The product no longer fit the core market it had been designed for at all. Development costs ended up exceeding 1 trillion yen, about 9 to 10 billion US dollars depending on exchange rate. Meanwhile, the competition obviously didn't sit idle. Embraer perfected its E-jets. Airbus bought Bombardier's C-Series and transformed the lower market segment with the A220, adding its global reach and credibility. Then COVID-19 hit, devastating regional demand. Under enormous financial pressure, Mitsubishi first suspended development in October 2020, then completely canceled the program in February 2023. The MRJ-90's maiden flight took place on November 11, 2015. The plane flew, it worked, but it was never put into service. After 15 years of work, the prototypes were dismantled. The dream died. For Japan, it was YS-11 déjà vu, but bigger and even more expensive. Burned twice, billions lost twice. Let's be clear, this isn't a question of engineering talent. Japan clearly has it. A world-class automotive industry, high-speed trains running like clockwork, robotics, electronics, materials science, all first-rate. Japanese engineers participate in manufacturing the most advanced commercial aircraft today. But a commercial aircraft requires 3 interrelated capabilities that Japan struggles to combine. First, engineering, designing, certifying, and integrating a complex machine with millions of parts. Next, capital, tens of billions in initial investment, with return on investment measured in decades, not years. Finally, commercial infrastructure, global sales, support, and political influence to convince airlines you'll still be there in 30 years. And here's the market dynamic that kills new entrants. Winner take all. Airlines avoid risks. They can't afford abandoned aircraft types with weak support. What happens if they buy your plane, then you go bankrupt in 5 years? Their aircraft becomes worthless, maintenance becomes expensive, resale drops sharply. Boeing and Airbus already offer massive fleets in service, global maintenance networks, deep leasing markets, and confidence in residual value. When an airline buys a 737 or A320, they know they can resell it later. There's a market. A new entrant like Mitsubishi faces brutal questions. Why should I trust the resale value? Will you still support this aircraft in 20 years? Japan struggled to answer these questions convincingly. Currency risk complicated things. Developing in yen but selling in dollars means exchange rate fluctuations require even higher volumes to break even, difficult for a newcomer. Unlike Embraer, which combined decades of state support with consistent global successes, and after 2 costly failures, there's institutional trauma. Bureaucrats and executives internalize that leading a complete commercial aircraft program to failure can ruin a career. It's safer to make wings for Boeing or supply parts for Airbus than to bet the company's future on a single national aircraft that might never fly. This conservatism isn't irrational. It reflects how severely failure is punished in this industry. Aviation programs live or die on 30-year horizons. A single mistake can cost billions. So why hasn't Japan succeeded in breaking into this market? First, no domestic market naturally large enough to birth a national champion. The United States has United, American, Delta, and Alaska massively buying American aircraft, guaranteed volume, a testing ground. Europe had several national airlines buying European, later grouped around Airbus with government support. Japan has JAL and ANA as major players. But 2 airlines can't support an aircraft program. A plane reserved for the domestic market alone doesn't justify its development cost. It must succeed globally from the start. That's incredibly difficult. Japan's aging population and stagnant growth further reduce appetite for these prestigious 20-30-year bets with low ROI, favoring quick gains in robotics over aviation's wild projects. Second, late entry into a saturated duopoly. When Japan is ready to build a modern airliner, Boeing and Airbus completely dominate the 150-plus seat segment. Embraer and Bombardier dominate regional jets. One could say that in the U.S., replacing regional jets like the E-175 will soon be a reality for all airlines. But scope clause limitations haven't changed. Mitsubishi couldn't wait. Every Japanese product would be more expensive to bring to market, harder to sell without a long track record against established aircraft families with proven economics and decades of refinement. Third, industrial policy and fragmentation. This leads to designs dictated by compromises, complex management structures, and unclear accountability when things derail. Compare that to a single entity that owns the program and its risk. Clear decisions, no committee compromises, no bureaucratic interference. Japan's consensus culture, an asset in many sectors, becomes a handicap in aircraft development where speed and decisive action count. Here's a counterintuitive truth. Japan has found its winning position. As a leading supplier, Japan can specialize in high-value components, wings, composite structures, fuselages. They leverage their manufacturing excellence without managing sales, marketing, or global support infrastructure. Revenue comes from long-term risk-sharing contracts with predictable production flows tied to Boeing and Airbus's success. When Boeing orders parts for 500 Dreamliners, Japanese suppliers collect on all 500. No negotiation with airlines, just industrial excellence. Lower visibility means less risk. If a program disappoints like the 747-8 or A380, suppliers suffer from reduced orders but avoid total failure. They diversify activities across multiple programs. This supplier strategy also aligns with Japan's new defense and space orientation. For example, The sixth-generation FXG cap fighter with the UK and Italy offering strategic returns without civil market volatility. If a completely Japanese aircraft flops, billions in losses, national shame, political crisis, broken careers, choosing the supplier role is smart risk management given the country's history. The great silent irony: without wings, systems, and structures made in Japan, some Western jets would be harder to produce or less performant. The 787 is composed of about one-third Japanese parts. Japan is a key pillar of global passenger aircraft manufacturing, but its name doesn't appear on the aircraft's nose. So why has Japan never built a successful airliner? The pieces come together now. Post-war bans erased its aviation advantage and broke institutional know-how. 7 years of forced absence created a hole that never really closed. The YS-11 taught Tokyo that 100% Japanese aircraft were financially risky. Policy then changed to aim at being the best supplier, no longer a direct competitor. When Japan tried again with the SpaceJet, certification problems, poor market assessment with scope clauses, delays, cost overruns, and catastrophic COVID timing stopped everything. 2 major attempts in over 60 years, 2 extremely painful lessons, billions in losses. Each failure reinforces an idea in government and industry: we're better as a partner than a leader. The risk-reward ratio doesn't hold. Can Japan try again? It would need a clear, stable target market, perhaps a next-generation hybrid electric regional aircraft or a specialized aircraft for short Asia-Pacific routes. Something Boeing and Airbus aren't focusing on: a defendable niche, the hybrid electric regional aircraft for Japanese island routes and ASEAN archipelagos, using new efficient technologies for short, frequent hops. It would need enormous government support and risk guarantees, a 20-30-year commitment with acceptance of lean profits the first decade. But the SpaceJet cancellation is still recent. No one wants to be the one who validates another multi-billion aircraft program that fails. Japanese demographics and economy are turning toward robotics, defense, space, and advanced materials. The sixth-generation fighter program with the UK and Italy opens a path to apply aerospace know-how without risking commercial markets. Being a world-class supplier is arguably more profitable, less risky, and more aligned with Japan's current industrial strategy. So Japan continues to be essential in passenger aviation, manufacturing the wings that make them fly, the fuselages that accommodate passengers, the structures that support loads, but never the name on the tail, never the brand airlines buy, never the manufacturer that takes home the glory and the risk. And perhaps after 2 costly lessons, that's exactly where Japan wants to stay.